Okay, hey everybody. So as promised, I'm going to just go through the review packet here, and I'm going to do one problem from every section. So again, as I suggested in the agenda, you can either watch me do the problem, then pause, then finish the section on your own, then play again for the next section, pause, do it, or you might want to watch this all as a review and then try to do the problems on your own. But either way, you do want to, again, see how much you know by doing the problems on your own and then check in with the answer key after you finish. So let's get started. So write each polynomial function in standard form, classify it by degree and number of terms. So again, we're going to get it in standard form, which means it has to be, everything needs to be combined that can be combined. So in this case, 4x plus 2x gives me 6x. X to the third cannot combine with anything. I want to write them in decreasing order of degrees, right? That's what standard form means. And then, so I have them, so this is standard form. And it is a degree 3, which is a cubic polynomial. And it has 2 terms, which is a binomial. So this is classified as a cubic binomial. So a reminder, you might want to look back at your notes and look at the special names we have for classifying a polynomial by degree and the special terms we have for number of terms. Okay, so again, I'm going to leave that to you guys to go look at, but that's an example of how this is done. Okay, find the zeros of each function and state the multiplicity if applicable. Okay. So I look at, so on these, we're just finding the zeros. So we're going to set each factor equal to 0 and solve. Now, x squared, you can think about that as x minus 0 squared, right? But if we set that equal to 0, we're going to get x equals 0, right? So that this squared means it has a multiplicity of 2. So one of our zeros for this is 0 itself, right, with a multiplicity of 2. Next, we set x plus 4 equal to 0, and we get negative 4. So that becomes one of our zeros or roots. And then we set x minus 7 equal to 0, and we get x equals to 7. So our zeros for this polynomial are 0, multiplicity of 2, negative 4, and 7. Okay. Again, if you need more review on that, you might want to go back, look at our notes, see what, see further detail. Okay. Let's look at the next one. So this one, the instructions say to write the polynomials in standard form with the following zeros. Okay, so now up here, they gave us factors and we found the zeros, right? Here, they're giving us zeros. We have to make the factors, then multiply them out into standard form. So remember, to do that, we plug everything into x minus, right? First, I'm going to say x minus 0, and then I'm going to, and I purposely chose one with a fraction, then I'm going to say x minus 2/3 and x minus a negative 5. Okay? Now, to clean this up, x minus 0 is just x. That's just going to be something we distribute at the end. No one wants to multiply with a fraction, and neither do I, so we're going to take this 3 in the denominator and move that to the x. So this factor becomes 3x minus 2, and then minus a negative becomes plus. Okay, so now this is what we're going to multiply together to get standard form. So first I'm going to FOIL these two, so I get 3x squared plus 15x minus 2x minus 10. I combine like terms, I get 3x squared plus 13x minus 10. Now I'm going to bring down this x and distribute it. So I get 3x to the third plus 13x squared minus 10x. Okay, So again, I want you to do that for the next 3. And remember, when you see like a multiplicity of 2, remember that's going to be, you're going to have x minus a negative 2, and then x minus 3, and x minus 3 again. Okay, just a little hint on that one. Over here, where you have x minus 0, multiplicity of 2, that's going to become just an x squared that you are going to distribute after you FOIL those. Okay, so again, just a little clue about those next 2. And again, I encourage you to look at the lesson. If you need some help on multiplying, you can go back and look at the lesson where we covered this. And again, finish these, and check your answers on the answer key. Okay, next one. Write the polynomial in factored form and find the zeros or roots for each function. Hint on these. Remove the GCF if you can, then factor and solve. So again, now we're starting at standard form. So we're starting here. We want to find the factors, then we want to solve them for zeros. Okay, again, remember that little chart that I showed you guys the very first lesson. Okay, so I'm going to do this one in red. So again, always on these 4 especially, always try to find the GCF. So here I can take out a GCF of 6 and of x, and I'm left with x squared minus 3. And again, one way to check is if I multiplied that back together, I would get my original equation. Now I'm going to set each factor equal to 0. So I set 6x equal to 0. I divide, I get x equal to 0. And I set x squared minus 3 equal to 0. I solve. I get x squared equals 3. I need to find what x squared equals, so I take the square root. And remember, the square root, anytime you take a square root, it gives you a plus and a minus. So I get plus or minus 3. So I'm finished. But remember, this was an x to the 3rd, so I am expecting 3 roots. And I found them. I found 0, plus 3, and minus 3. So again, the highest term here on all of these should tell you how many roots you should find. Okay? All right, now, then we went into different ways of factoring, right? So this first section, you should be able to use everything we used in quadratic. So GCF, reverse FOIL, difference of squares, solving by the square root, AC method if necessary. Now we're just getting into some of the newer methods we learned. So for instance, we learned the grouping method, which is used when you have terms. Again, similar to like an AC method factoring, we begin by splitting it down the middle, right after the second term. Take out a GCF over on the left, and I can take out x squared. And I'm left with x minus 7. Over here, I bring down my plus, and I can take out a 2, and I'm left with x minus 7. So just like in grouping, my parentheses have to match. They do. So my first factor is x minus 7. My second factor is the GCFs I took out, which is x squared plus 2. Now I set them equal to 0. And once again, I started with a degree of 3. So I expect 3 roots. So I set x minus 7 equal to 0. I solve, I get x equals 7. I set x squared plus 2 equal to 0. I solve, I get x squared equals negative 2. There again, I have to take the square root. So I get x equals plus or minus negative radical 2 is going to become I radical 2. The radical has to stay, again, because there's no perfect square root in 2. But I can take that I out because it has because it's a negative radical. Okay, so I was expecting 3 roots. With this plus or minus, I got my 3 roots. Okay, there again. If you have questions about that or you need to do some review, go back and look. There's videos even of our classes then, or go back and look at the notes. Okay. So you're going to use the grouping method on 19 and 20. Be careful here because you're going to need to set it equal to 0, right? So you might want to add 10. Okay, I'll let that go. Okay. Next, another new method we learned was sum and difference of cubes. You will always be given the formulas. Okay. I'm going to again do the one here in red. It's an addition, so I'm going to be using this one. Okay, first I want to rewrite it as what is being cubed. So my x is being cubed, and with 27, my 3 is being cubed. So the x represents the a in the formula, and the 3 represents the b. So I go up to this side of the formula and I plug it in. A plus b is going to be x plus 3. A squared minus a times b is going to give me x squared minus 3x, plus b squared is going to be plus 3 squared, which is 9. I set this equal to 0, and I get x equals negative 3. That's one root. I need 3. On this side, I always have to do the quadratic formula, okay? And remember the quadratic formula. Because there's no other way to solve these other than using the quadratic formula for the second piece. So I get x equals negative b, which is, sorry girls, which is just going to be negative 3 plus or minus square root of b squared minus 4ac all over 2a. I get negative 3 plus or minus 9 minus 36 over 2. Negative 3 plus or minus radical negative 27 over 2. Negative 3 plus or minus, again, remember I bring out that negative 27. I bring an I out, and I get radical 9, radical 3. So I get 3i radical 3. So I get negative 3 plus or minus 3i radical 3 over 2. So again, I was looking for 3 roots. This is 1. And then this plus or minus on my quadratic formula solution gives me the other 2. Okay? So again, work these next 2 out. And remember, you want to, the key piece here is rewriting it as to what is being cubed. So what is being cubed with a 64 and what is being cubed with an 8. Okay. A substitution. Again, another method we learned where the key here is to let a equal x squared. So I'm going to again do the red one down here. If I use this substitution, then x to the 4th can be written as a squared. 2x squared can be written as 2a minus 24. Now it becomes a quadratic that I can easily factor. What multiplies to negative 24 adds to 2, which would be a plus 6, a minus 4. Now I want to reverse the substitution and put it back to x squared. So now I have x squared plus 6 and x squared minus 4. I solve those, I get x squared plus 6 equals 0. I get x squared equals negative 6. I take the square root. X equals plus or minus I radical 6. Again, the I, because it was negative, and with 6, nothing can simplify. The second piece, I say x squared minus 4 equals 0. Add 4. I get x squared equals 4. I take the square root. 4 is positive and a perfect square, so x equals plus or minus 2. Again, I started with an x to the 4th, so I'm expecting 4 roots, plus or minus I radical 6, plus or minus 2 gives me those 4 roots. Okay? All right, next is end behavior. remember we studied end behavior as arrows, right? It's either up, up. If it's a positive x, an even exponent, it's down. Do a quick review here for you guys. It's down, down. If it's a negative x and the power is even, it is down, up. If it's a positive x and the power is odd, and it's an up, down. If it's a negative x and the power is odd. Okay, again, you look at only the first term or the term with the highest degree, which should be this 7x to the third. It is an odd power, and 7x to the third is positive. So the end behavior is going to be down and then up. And boom, I'm finished. Okay. Next one, find the real solutions of each using the calculator. So I'm going to pull up my calculator. I'm going to do this red one again. So I'm going to enter that. 2x to the third minus 4x squared. And then minus 5x. Remember, you always need to set it equal to 0, right? I have to subtract 5x from 5. So show that. To die. Okay, so I get this. Now so I plug that in, I hit graph. Remember, if yours is off at all, like uneven, you can hit zoom 6, and that will center it. I'd like to get a little bit closer to this one, so I'm going to go ahead and hit in. I'm going to go to zoom, go down to zoom in, and I'm going to hit, actually that took me a little too far. I'm going to keep it like this. Never mind. Okay, but I have 3 roots. I've got this one, and this one. So I'm going to hit second, trace. I'm looking for the zeros, so I'm going to hit 2. And now it tells me left bound. So only using left and right arrows, I'm going to use this left arrow and get it to the left of this first root, which is below it. I hit enter, tells me right bound. I want to get it to the right of that first root, which is just above it. So there's enough showing here that it's to get above that root. I hit enter. Guess, I hit enter again. Now it tells me 0, and that says negative 0.87. So my first root, negative 0.087. And then I go to my next one. I do the same thing. Second trace. I go down to number 2. I hit 0. I get to the left, which would be up here. I hit enter. I get to the right, which is down below. Again, because of the curve of the graph. I can go here. I could go down here. I could go anywhere below it. It doesn't make any difference where. I hit enter, guess, and now it tells me that 0 is at x equals 0. So that's my third root. I do it again. I need this third one over here now. So I do second trace. I want the 0. I go down. Again, I just have to get to the left of it. I could stay down here if I wanted, or I could get a little bit closer. It doesn't make any difference. I hit enter. I have to get to the right of it, which is going to be above it. My cursor went right up here, so that's about as close as I'm going to get. I hit enter, and it tells me 2.07. So my third root is 2.07. Okay. Again, I was expecting 3. You won't always get 3 because the calculator will only give you the real solutions. But in this case, it did have 3 real solutions. Okay. The example I've left for you to do is a 4th root. So you will have 4, and there are 4 real roots. Okay. I made sure of that for this equation. Okay. Last is synthetic division. So again, I also hope you guys checked your homework that is posted for synthetic division. So should be relatively, fresh in your brain, but I will go ahead and review this real quick. So I'm dividing by x plus 3, so I put a -3 over here in the corner. Then I line up my coefficients. So my coefficient of this, of x squared is 1. My coefficient of -13x is -13. My coefficient of -48 is -48. I draw a total line. I bring down the 1. I multiply. -3 times 1 is -3. I add down, I get -16. Peter. I multiply -3 times -16, I get +48. I add down, I get 0. That tells me x plus 3 is a factor of my original equation. And when I build my original equation, or my resulting equation, again, I started with an x to this x squared. My answer is going to be 1 less than that degree. So I'm going to start with x to the 0. Sorry. I'm going to start with x to the first. So this 1 is my coefficient for x to the first, and I just get a constant, x minus 16, and I get a remainder of 0. Okay. Now I did talk about being careful if a x was missing, and none of these, it looks like we're actually missing a term, so you won't have to be too concerned about that. I gave you guys 1. Again, because this is kind of fresh in your brains from class, I just have given you 1 to where I want you to use synthetic division for the given factor and then completely factor it. So again, you're going to divide by -5, and then you should end up with a remainder of 0. Okay? If you don't, then you made a mistake somewhere. Okay, and then you want to take your resulting equation, your answer, and further factor it. Right? So find more factors, because you should find a total of 3 factors. Okay, so I hope this gives you a nice little review. You should complete the packet on your own. So that is your assignment for this Digital Learning Day for both C, G, and H blocks. I want you to complete the packet and then follow the directions in the agenda. So again, this just says check your homework. The answer key is posted. Finish the review packet. The answer key to the review packet will also be posted, but please use it wisely. Okay, the polynomial test will be next class, Thursday or Friday, depending on which block you're in. And once again, you will be allowed to use your review guide, okay? But it needs to be on paper, because you will not be allowed to search OneNote during the test, okay? So to use your review guide, I recommend either writing it out on paper, just looking at it in OneNote for the problems, but writing it out on paper, taking pictures of those to post to OneNote to get credit for completing the review guide, but then you have all your work available to use for the test. Or if you have a printer available, you could do all your work in OneNote and then print it and have that for the test, okay? I also encourage you, if there's any notes you want to write down on your review guide, that is perfectly fine too. Don't feel like you're cheating or anything if you write some extra steps to help you remember, okay? I will be sending out an invite to a Teams review session on Wednesday at 1 o'clock for all of the blocks together. For anyone who wants to attend, I'll just be going over the review guide and taking any questions. Okay, well, that's it for this video. Hope you guys enjoy your Digital Learning Day. I think it's supposed to be beautiful weather. And I will see you guys on Teams on Wednesday for the review session, or in class Wednesday or Thursday. All right, great, guys. I'll see you then. Bye.